Hi everyone, this will be a quick lesson on how to complete the square. In our first example, we have x squared plus 6x plus 1. I've drawn a square here so you can visualize the process. Pretend these are straight lines. So when we complete the square, visually it is just that. Let's have a look at how we do this. So we have x squared plus 6x. That tells us that the sides of this square, since they must be the same length, would have to be x plus 3 and x plus 3, because you can see that that's how we get x squared, 2 lots of 3x, which gives us the 6x. And then that last little square must be a 9 for this square to be completed. So what that means is, to turn this into a perfect square, what we need to do is add 9 to x squared plus 6x. But then since we can't change the expression, otherwise we'd change the expression completely, we need to take away 8. Because 9 take 8 equals the plus 1 that we have in our original expression. So now we can turn x squared plus 6x plus 9 into x plus 3 all squared minus 8. Let's have a look at the second example. So now our x term is an odd number. This makes it a little bit trickier because we're going to have to deal with fractions now. So similar to before, we always take the x term and halve it. So half of 5 is 5 on 2. We want to keep things as fractions. And that helps us visualize x squared plus 5x. And then to complete this square, we need to add on 5 on 2 times 5 on 2, so the square of 5 on 2, which is 25 on 4. So let's write this as x squared plus 5x plus 25 on 4. And now we need to subtract a number to get it back to -3. So take your time doing this, but here we would have to subtract 37 on 4. Okay, because that would give us -12 on 4, which is equivalent to -3. So once we complete this square, let's make a perfect square. It is going to be x plus 5 on 2 all squared, take 37 on 4. It's a little bit squished up, that's all right. And our final example here, we have 3x squared minus 6x minus 1. Now we have a coefficient of 3 in front of the x squared. So we're actually going to factorize that out, because when we complete the square, we want to make sure that our x squared term has a coefficient of 1. That just makes it so much more efficient to deal with. So right now, we are trying to complete the square with x squared minus 2x. So right now in our diagram, that's what we have. So that means our side lengths of the square would have to be x minus 1 and x minus 1. Meaning that we would have to add 1 to complete the square. So let's go ahead and do that. But since we've added 1, we have to subtract 1 to keep the expression the same as before. Haven't changed the value. That's very important. Leave that -1 on the outside. So now what I'm going to do is just multiply the last -1 in the bracket by the 3 and just take it out of the bracket like so, because then we can see we have a perfect square there, and then on the outside we have a -4. Hope that helps you. See you next time.